Good day to everyone. Let's try to solve this problem 2.16. Determine V naught in the circuit in figure 2.8. So normally, uh, so how do you solve this kind of problem? Well, first, of course, based on circuit analysis, we have our checklist of techniques that we are going to use. We can use the Ohm's law. We can use the Ohm's law plus the passive sign convention. For instance, you have a voltage. You have a voltage source that is plus minus. If your direction of travel is going on this way when performing the KVL, then the voltage V must have a positive sign. But if your direction of travel is going to the from right to left, then you would consider a negative V. So that's the passive sign convention for passive sign convention for KVL and Ohm's law. And finally, we have the KVL technique. Now, in this case, for determining V naught, well, what we can do is first we perform the KVL on, let's say, loop 1 so that we can have an equation for V naught. So let's go ahead and do that. We apply KVL on loop 1. So first, let's start in this point. So that would be negative 10 volts. In this case, we have our direction of travel is clockwise, so we assume that the current direction is traveling from plus to minus. And we'll call this voltage V. So that would be positive V. And then for V naught, we have positive V naught, which is equivalent to 0. Then we have already the equation for V naught that is equivalent to 10 minus V. Okay, let this be equation 1. So what is V? Now, by Ohm's law, so and we must also consider the passive sign convention. So V is equivalent to the current that is flowing in this 16 ohm resistor. So let's call this current I. So V is by the passive sign convention. So since the current is entering the positive terminal of the resistor, assuming that would be positive 16 I. So by Ohm's law. Okay. So, now we substitute equation 2 to equation 1. Then we have V naught equals 10 minus 16I. We'll name this equation 1 prime. Now let's shift our understanding in determining I this time. So how can we determine I in this circuit? Well, when you analyze the circuit, you can actually say that current I also flows in this direction, I. So we can perform KVL on the or in the outer loop. Let's call this loop 2. Okay. And we apply KVL on loop 2 for I. Oops. For I. Then, so let's start again in this point. So we're following the passive sign convention. So that would be negative 10 volts. And then we already solved V here. V is 16 I. So we can substitute it and replace V as positive 16I. And as for 14 ohms, this is also plus to minus because we're assuming that the current moves from left to right. So that's 14I. Then here comes the positive, the voltage source, 25 volts. So current is entering the positive terminal, or I mean our direction of travel is entering the positive terminal. So therefore, we're going to have a positive 25 volts. And then we equate this to 0. So now we can use our calculator to solve for I using the shift solve function. Negative 10 plus 16 alpha x plus 14 alpha x plus 25. Then alpha equals 0. So the answer for the current is negative 0.5 amperes. So the negative sign means that our assumed direction is opposite to the current direction. But the magnitude is same. However, magnitude is same. Okay, now that we have the current, negative 0.5 amperes, so this doesn't mean that you're going to, say, okay, so since I have a negative value, I must force it to be positive 0.5. No, you don't do that, because our analysis will be violated if you perform this, like applying the positive sign on the current. You don't do that. You have to be consistent with your solution. So if you got a negative 0.5 amperes for the current, then let it be. You can just apply this explanation that the assumed direction is opposite to the current direction, but you must remain consistent. Therefore, still the value that we're going to substitute in solving for V naught in this in this equation will be negative 0.5 amperes. So you will not force it to be positive, because we have to be consistent with our solution. Now, finally, therefore, we substitute I in equation 1 prime. Therefore, V naught is equivalent to 10 times negative 16 times negative 0.5. V naught is equivalent to 10. This is positive. So 16 times, like that's just like 1/2. So 16 times 1/2, that is 8. Therefore, V naught is 18 volts. That's the answer. Thanks for watching.